Here we're asked to calculate the concentration of the added hydroxide solution. We're adding two solutions. We're given a net ionic equation. We're going to start with a BCA table. We want to calculate the initial moles of H+. We look at the source of the H+, which is HCl. We have a volume and a concentration, so we can easily calculate the moles. All right, so we have 0.540 initial moles of H+. We can calculate the final moles of H+, because we have the concentration of the final solution. And if we add the two volumes together, we can get the volume of the final solution. So we enter the final moles of H+ into our BCA table. And we see that in order to go from 0.54 to 0.231, we had to have lost 0.309 moles of H+. Therefore, we know an equal amount of hydroxide reacted, which meant that initially we had 0.309 moles of hydroxide before the reaction occurred. So now we can calculate the concentration of the hydroxide we added as being 0.309 moles in 0.100 milliliters, because this is the volume of the NaOH that was added. So doing the math, we see that our concentration of hydroxide that was added is 3.09, or with 2 sig figs, 3.1 moles per liter.